Okay, so in our last class, we have started discussing PN junction diode, and we have briefly discussed about the characteristics of diode. Okay, so I will recap this, and then we will uh, proceed. So, ideal diode. Okay, 1 minute. Mm, Some students are waiting. Okay, admit. So please be on time. It is a request that please be on time.
So you're on mute right now.
Now you can hear me.
Yes, sir.
Okay, so please log in within 10 minutes. After 10 minutes, I won't be admitting any students because the flow gets disturbed. So we have started discussing PN junction diode. So this is the symbol of PN junction diode. Okay, this is the symbol of PN junction diode. This cathode is having this is P type P side. This is N side. This side is having P type semiconductor. The right side is having N type semiconductor. So this is cathode. This is anode. So it is basically a two-terminal device that conducts only in one direction. Okay. So the direction is direction of current. Basically, it conducts current only in one direction. That is from P to N. And when it's conduct, it will conduct when the relative voltage at P terminal is greater than the relative voltage at N terminal. So Vp should be greater than Vn. And whenever this is the case, we say that diode is in forward bias condition. So we say that diode is in forward bias configuration. And when Vp is less than equal to Vn, we say that the diode is in reverse bias configuration. So overall, in you can say that your diode PN junction diode only conduct when it is in forward bias configuration. So okay, so now starting with ideal diode. Okay, so first we will consider the forward bias case. So I have taken a very simple circuit with a 10-volt battery source. The positive side is connected to P terminal. We have a resistance of 10 ohm. We have a resistance of 10 ohm, and the negative side is connected to the N side is connected to the negative terminal of the battery via this resistance. Okay, so we can say that at this point we can say that Vp will be obviously greater than Vn. This is the case. So your diode is in forward bias condition, and you can make a equivalent circuit. So this is a equivalent circuit where you will be replacing your diode with a simple wire. Okay, so this circuit will have a current id flowing in the clockwise direction, and let's say vd is the voltage drop across the diode. Vd is given by basically Vp minus Vn. Okay, so we positive positive is with respect to P terminal. So Vp minus Vn is Vd. So in this case, you can see that Vp and Vn are connected via wire. So Vp and Vn are Vp will be equal to Vn. Hence, we can say that Vd is zero. So voltage drop across the diode is zero. And IPN, that is the current flowing from P to N, current flowing in the forward direction. IPN is ID, and that can be calculated simply by applying Ohm's law or Kirchhoff voltage law. So 10 volt by 10 ohm, it is 1 ampere. And voltage drop across this resistance VR, if this is the voltage drop across resistance VR, so this is nothing but ID into R. So again, it will be 10 volts. Okay, so you can apply KVL or you can apply Ohm's law, anything you want. So you can conclude that ideal diode behaves as a short circuit in forward bias configuration. Meaning to I mean what I mean to say that the resistance of the diode will be zero whenever it is in forward bias condition. The resistance of the diode is zero. And second thing is that the voltage drop across the diode VD will be zero. Okay, and ID depends on the external resistance. Okay, so whatever will be the value of R, V by R, that will be the value of ID. And if I want to show it graphically, this will be this is I will be plotted on y-axis, voltage VD. I want to plot VD. VD will be plotted on x-axis. Okay, so remember that I am not plotting this V external. I want this VD. So VD versus I. So voltage drop across diode is zero, and for this zero voltage drop, the current is 1 ampere. The current is 1 ampere. So this current depends on the external circuit. So this is how you can represent the IV characteristics of your diode in forward bias region. So this is the graphical representation. Okay, just by reversing the connection. Okay, now connect N side to the positive terminal of the battery, and the P side will be connected via this resistance to this negative terminal of the battery. So this configuration is known as reverse bias. Okay, same circuit, just the connections of the diode is reverse. So equivalent circuit for this will be, okay, so uh, open circuit. You replace the diode, simply replace the diode. That's it. So this means that we are having a open circuit. So the loop is broken. Okay, so obviously ID ID will be equal to zero because the path is not continuous. And VR, since ID is zero, so obviously VR will be equal to zero since no current is flowing. So zero current into R gives you zero. And VP minus VN, VP minus VN is again VD. We always measure VD voltage drop across diode. So that will be minus 10 volt. You can apply KVL. Okay, so VP minus VN will give you minus 10 volt. Okay, so magnitude of VD will be equal to the external voltage, and ID is zero and VR is zero. So the same thing. Okay. So the same thing, this forward bias configuration, this kind of thing, and this reverse bias configuration. This is your experiment number 2 that you have to perform in your lab. Okay, and we can again represent this graphically. So VD is negative, so VD will be on the left hand side, and corresponding ID is zero. So no matter whatever the value of this external voltage, if it is 10 volt or it is 20 volt, you always have a zero value of current. Okay, and this VD, this line depends on the external voltage. So this VD, magnitude of VD will be exactly equal to the external voltage. So this is how you graphically represent uh, the reverse bias characteristics of ideal PN junction diode. So till now I was talking about ideal diode. Okay. Okay, so this is the IV characteristics, forward bias as well as reverse bias. So in forward bias, VD is zero and you have some current. That current depends on external circuit. And in reverse bias, that will be on negative x-axis. So reverse bias, no matter whatever is the value of the voltage, current will be always zero. So this is the IV characteristics of ideal diode. Now moving to real diode, okay, because in practical, we have to use real diode. So this is the symbol of PN junction diode. So intrinsic silicon is taken. Intrinsic silicon is taken. Okay, so some portion is doped with p-type impurities, and the remaining portion is doped with n-type impurities. So this is how you fabricate a PN junction diode. It is not like you have a p-type semiconductor and a different n-type semiconductor and you can just attach it by some glue or like, okay, so don't get confused. A single intrinsic silicon crystal is being converted to p-type, some portion is converted to p-type by okay, क्या हो गया? Some portion is converted to p-type, remaining portion is converted to n-type. Okay, so on p side we have, you can see we have, I have shown this symbol, a circle with minus sign inside and plus side outside. So this is acceptor atom with one vacancy, one hole associated with it. Each acceptor atom is having one hole associated with it. So this is how we represent this. The plus sign, only plus sign, if I am drawing only plus sign, this means that this is the holes. Okay, so in p-type semiconductor, holes are majority charge carriers. And this circle with minus sign, I have not drawn plus sign on it. So this is representing donor ions. So the net charge on this is now 1 negative. Okay, so this holes is, whenever this hole will get in free condition by absorbing some amount of energy. Okay, so you have free holes inside the crystal, and you have this leftover donor ions. So this donor ion is in bonded form. It is forming bond with nearby surrounding by silicon atoms. Okay, and it has lost it one positive charge, so net charge on it is now -1. And this is free electrons. So I have drawn a small amount of free electrons in the p side. So these are nothing but a minority charge carriers. This this is because of thermal generation. Okay, similarly on n side you have donor atoms. So donor atom having one extra electron, 4 electron is paired by the surrounding 4 silicon atom in the crystal, and 1 electron is loosely bounded. And when this 1 electron absorbs some energy, and whenever it is in free state, you have one free electron. So this is the majority charge carrier in n-type semiconductor, and you have this only plus sign. So this is representing donor ion having one positive charge. Phosphorus atom lost it one valence electron. So net positive charge on it will be +1. And apart from that, you have some holes, very few amount of holes. So that will be, I have drawn this red color plus sign. So you have this is a donor atom. So we ideally we say that each donor atom has contributed 1 electron. Okay, so I have drawn this in pairs. On the p side, acceptor atom with holes. On the n side, donor atom with electrons. And on p side, we have very less amount of electrons. On n side, we have very less amount of holes. So this is the overall scenario. Okay, now we have three cases based on the voltages on this. These are external metal contacts by using which you can connect this diode to external circuit. So this is P terminal, this is N terminal. You can say this is cathode, this is anode. So based on the voltages on P and N terminal, you have three cases. First case is V external is 0. No external voltage is applied. You have not applied any external voltage. So this is the first case. We will see what is the condition of, what is the internal dynamics of this diode when we have applied no external voltage. Second case, when we have applied when Vp is less than Vn. So this is the condition for the reverse bias case. And third case is Vp is greater than Vn. So this is the condition for forward bias case. So we will see all the cases one by one. So case one, P external is 0. We have not applied any external voltage. So practically your diode is not connected to any circuit. Okay, so you have this on P side, you are having uh, acceptor atom. Each acceptor atom is having one hole associated with it. Okay, and on n side you have a donor atom, and each donor atom is having one electron associated with it. Okay, so by absorbing a small amount of energy, this holes and electron can be in free state, and then they can move in the crystal accordingly. So there is one term called diffusion. You might have heard this in your chemist plus 2 chemistry. This is defined for gas molecules. So diffusion is something like, suppose you have some rooms, and if you release some gas molecules on the one of the corners, so this gas molecules will try to distribute in the room uniformly. Okay, this is high density region initially. So the molecule will spread and it will distribute across the room uniformly. So uh, after after a long time, let's say t equal to infinity, whenever you take any volume of the room, equal volume. Okay, these are four different volumes. So number of gas molecules in each volume, in each of this volume will be equal. So this particles, gas particle try to distribute in a given space equally. So this is called diffusion. So this is also applicable in this PN junction diode. Okay, so you can see that in the p side we have majority charge carriers as holes, and on n side we have electrons. So this hole will move from p to n. So this hole will try to get diffused from p side to n side. Okay, also there is a attraction, charge attraction. Okay, plus attract minus, minus attract plus. So this hole will get attracted from this minus will get attracted from this plus side. Okay, so holes will move from p to n side. Moving means diffusing. Similarly, the electron will move from n to p side. Okay, and plus moving this side, minus moving this side. Okay, and they will then combine. Plus electron and holes then combines. So plus combine with minus give you what? A neutral. 1 plus 1 minus 1 gives you 0. Neutral. Okay, so let's say that this electron is moving from n side to p side. So this is electron started moving. Now it is in p side region. Now this electron is minority charge carrier in this p side region. Okay, so eventually whenever it is moving, it is losing its energy, and after some time it will get attracted by this hole. Okay, so let's say that this electron comes, enter into this p region, and this hole attracted. So plus minus becomes 0. Okay, so I am removing this plus sign now. Means that now this plus, I have only this minus sign. So this is now donor, sorry, this is now acceptor ion. Similarly, this electron enter into this and p side. Okay, and this get captured by this hole. So again, we have lost this electron, we have lost hole. So electron and holes combines. Similarly, this will also combine. So I can delete this. Okay, so this is, now you can see this region. So on the ends, this is the junction, this is the border of p and n, and we have some extra regions. Okay, so you can see on the n side we are having positively charged donor ions. So these are donor ions, positively charged donor ions. Okay, and on n side, sorry, this was an n side. On p side we have negatively charged acceptor ions. Yes, Rishabh, 1 minute. Yes, Rishabh, you can unmute yourself.
सर आपने पी साइड में नेगेटिव पे वो बना सर्कल बना के उसमें पॉजिटिव क्यों लिखा है, मतलब क्योंकि वैसे तो मेजॉरिटी तो वो है ना, पॉजिटिव है.
भाई मैंने पिछली स्लाइड में और क्या समझा रहा था मैं कि ये नोमेनक्लेचर क्या है. डोनर आयन, दिस इज पी साइड, दिस इज एक्सेप्टर आयन, और ये जो बाहर बना है ये होल्स है, ये फ्री स्टेट में चले गया तो होल फ्री स्टेट में आ गए, और डोनर डोनर आयन ने एक अपना होल लॉस कर दिया तो उस पर नेट नेगेटिव चार्ज आ गया. यही तो बताया मैंने, इसका
ओके
उल्टा
सर.
है साइड में. इसलिए तो मैंने ये स्लाइड स्पेशली बनाई थी नोमेनक्लेचर समझाने के लिए. ओके, सो we have contrary on p side we have negatively charged acceptor ion. So this is called depletion region. Depletion region, because in this region there are no free electrons and no free holes. Electron and holes combined. Okay, and the net result is 0. Okay, so this is phosphorus ion having one positive charge and it is fixed. It is fixed. It is bounded. It is forming covalent bond with the surrounding silicon atom, and this is boron atom. It is also fixed, so it cannot move. It cannot contribute to the flow of current. You have free electron and hole that got combined. Okay, so this is the case. Okay, so now what will happen? Again, this hole will flow. This hole will flow to n side, and the electron will flow to n side. So this means that if this continues, flowing of holes from p to n and flowing of electron from n to p, eventually at the end all the free charge carrier will combine. This crystal will have zero free charge carriers. So then how it can be stopped? What is the use of this? Okay, from we have the this doping method is very expensive, very time taking, and by using a very expensive and time taking method, you have created p type and n type semiconductor. And what you are seeing is that eventually the free charge carriers are getting lost. Okay, so now let's see whether it will be continued or it will be stopped by some other process. So okay, so in this depletion region, you can see that you have a layer of positive charge on n side, you have a layer of negative charge on p side. So there will be a electric field. This will be a kind of dielectric. So electric field flow from E to N. I called it as E internal because of internal ion. Okay, so now you know that this plus charge, when plus charge cannot go opposite direction, this plus charge cannot oppose this electric field which is from N to P, and this minus charge, it cannot flow from this in the direction of this electric field. So what this electric field will do? Okay, after some time, when you have when there will be sufficient depletion region, you have sufficient amount of positive charge and negative charge. So this E will increase gradually. This E will increase, and after some time, what will happen? This E will be sufficient to stop the motion of positive charge from P to N and the motion of negative charge from E to N, meaning to say that the kinetic energy of this free charge carrier will be equivalent to the energy uh, in opposite direction because of this electron. So this will be the case. That's why we say that this. That's why we say this as a depletion region, meaning to say that no free charge carrier. Okay, so now you know that we have a formula that V is equal to minus ED. Although this is in differential equation form, V is minus E times D. So this V corresponding to this E value, and this D is the width of the depletion region. So the value of this is approximately 0.7 volt for silicon, and this is approximately 0.3 volt for germanium. Okay, I am writing approximately, okay, because I have to give you some values. But whenever you will be doing practical, you will see that it starts from 0.5 and you have like 0.6. Okay, so after 0.5, it increases by a very small quantity. Okay, but it is not fixed. But mathematically, when we will be solving problems, we will take it as zero point 0.7 for silicon and zero point 0.3 for germanium. Okay. So this is the case. So this internal electric field will resist the flow of electron, and eventually at some depth d, this process will stop. So because of this, you will be having still some free amount of holes in p side and free amount of electron in n side. Now case 2, reverse bias. I have I have taken one external voltage source, and negative terminal is connected to now p side, and the positive terminal is now connected to n side. Okay, so we have now, because of this V, we will have additional electric field. I called it as E external. So we have now two component of electric field. One electric field because of this internal this internal generation, and second because of this external voltage source. So we have two electric fields in the same direction from N side to P side. So E net will be minus. I am writing this as minus of E internal plus E external, because I am considering this as positive direction, this as negative direction. So E net will be minus of E internal plus E external. So direction will be from N to P. So that direction I will consider it as negative. So if the width of the depletion region in this case is D, and let's say that this is D1, so it is obvious that D1 will be greater than D. So width of the depletion region will increase, because this this negative charge is attracting free holes to this. Okay, this negative terminal is attracting free holes. So further there will be loss of free charges, free holes from the P side, and this positive terminal is attracting free electrons. So further few free electrons will be get depleted into the battery. Okay, so this width of this depletion region is going to increase. So D1 will be, yes Rishabh. Okay. Okay, I cannot unmute. Okay, मैं अनम्यूट कर रहा हूँ, आप हो नहीं रहे हो, पता नहीं क्यों. Okay, let me try this. Can you unmute yourself?
Yes, sir. Sir.
हाँ जी पूछिए.
Sir, I'm not able to understand the main reason for the creation of depletion layer. Like N side में positive charge आ गया और P side में negative charge आ गया.
आप
और in a
स्टार्टिंग से
particular.
लेक्चर में आए हो या अभी आए हो?
नहीं सर, मैं starting से हूँ.
Okay.
Sir, as in I heard that, but I was not able to get it.
नहीं, ये कहाँ पे? यहाँ पे इस साइड में हम बात करें इधर.
Sir, this thing, yes sir. Sir, why there is positive charge on the N side and negative charge on the P side only in the depletion layer, that part?
This is not positive charge. This is okay. This is not positive charge. This is positively charged donor ion, and this is negatively charged acceptor ion. They are fixed. इसने बॉन्ड बना रखा है सिलिकॉन से, और पहले इसके पास एक फ्री इलेक्ट्रॉन था. इसका फ्री इलेक्ट्रॉन होल के साथ कंबाइन हो गया. ठीक है, एनर्जी उसने गेन करके वो फ्री स्टेट में आ गया. और किस होल के साथ कंबाइन हुआ? जो पी साइड में जो होल था उसके साथ कंबाइन हुआ. तो इस बोरॉन, ये बोरॉन एटम था, इसने अपना एक होल लॉस कर दिया, तो इस पे अब नेट नेगेटिव माइनस आ गया. इसने अपना एक इलेक्ट्रॉन लॉस कर दिया, तो इस पे नेट नेगेटिव पॉजिटिव आ गया. सो इसलिए हम कह रहे हैं कि ये फिक्स्ड आयंस है. दे आर पॉजिटिवली चार्ज डोनर आयन. दे आर फिक्स्ड. दे आर फॉर्मिंग कोवेलेंट बॉन्ड विद सिलिकॉन. आप लग रहा है वो प्री रिक्विसाइट वीडियोस नहीं देखे आपने अच्छे से. आपने वो, मैंने हालांकि उसको समझाया था, बट स्टिल आपने वो प्री रिक्विसाइट वीडियोस नहीं देखे. आप प्लीज उसको देखिए एक बार, अदरवाइज तो मैं यही समझाते रह जाऊंगा ये +2 वाली चीज, क्योंकि हमें आगे भी बढ़ना है चीजों में, डेरिवेशन में. आप प्लीज उस वीडियो को एक बार देखिए, आपको एज एक्टिविटी वो टेक भी करना है. तो ये फिक्स्ड आयंस है, ना कि फ्री. तो ये जो मैंने सर्कल के बाहर बना रखे, ये फ्री स्टेट में है. ये मूव कर सकते हैं, ये मूव नहीं कर सकते. तो बॉर्डर के पास जो बॉर्डर होता है, वहां पे हमारे पास एन साइड में ये हमारे पास फिक्स्ड आयंस रह जाएंगे जिसपे पॉजिटिव चार्ज होगा, और पी साइड में हमारे पास फिक्स्ड आयन रह जाएंगे जिसपे नेगेटिव चार्ज होगा. तो इस रीजन में कोई भी फ्री चार्ज है ही नहीं. तभी हम इसको कह ले डिप्लीट मतलब नहीं है, वहां पे फ्री चार्ज नहीं है. तो ये प्रोसेस बॉर्डर, ऑब्वियसली बॉर्डर के पास ही होगा. जो भी कॉन्सिक्वेंसेस होते हैं वो बॉर्डर के पास ही होता है, जब वो बॉर्डर से होल्स यहाँ से यहाँ जाएंगे, ऐसे है इस वजह से. और जब आप यहाँ पे और एक रिवर्स बायस में इसको डाल दोगे, तो ये ये क्या करेगा, ये नेगेटिव है, ये प्लस फ्री होल्स को अपनी तरफ अट्रैक्ट करेगा, तो और इस पी साइड से फ्री होल्स कम होने लगेंगे, और ये प्लस वाला जो है प्लस टर्मिनल फ्री इलेक्ट्रॉन्स को अपनी तरफ अट्रैक्ट करेगा, तो इस एन साइड से और फ्री इलेक्ट्रॉन्स कम होने लगेंगे, तो कॉन्सिक्वेंस ये होगा कि उसकी विड्थ बढ़ती जाएगी, उसकी जितनी आप ये लगाओगे उसके प्रोपोर्शन में ये बढ़ती जाएगी। ओके, सो विड्थ ऑफ डिप्लीशन रीजन विल इंक्रीज, ई नेट विल अपोज द फ्लो ऑफ मेजॉरिटी चार्ज कैरियर, मेजॉरिटी चार्ज कैरियर फ्लो नहीं हो सकते, हमें करंट पी टू एन डायरेक्शन में चाहिए तो वो फ्लो नहीं हो सकता। However, it will support the flow of minority charge carriers. So you can see that you have holes as a minority charge carrier in N terminal, electron as a minority charge carrier in P terminal. So because of this electric field, this holes some plus charge हमेशा electric field की direction में flow करते हैं और electron opposite direction में. So because of this electric field from N to P, this hole will flow from N side to P side, and this electron will flow from this P to N side. So you will be having some current IS in the anti-clockwise direction, and this IS is known as a reverse saturation current from N to P. Okay, this is very less. You जब भी आप इसको experiment करोगे तो आप देखोगे ये pico ampere, femto ampere, pico means 10 to the power minus 12, femto means 10 to the power minus 15, इस order में है ये. Okay, so you will be, you might have some groups might have completed their second experiment, so उसमें जब reverse bias में करोगे तो ये IS कुछ आएगा इस order में. And why this IS is coming? Ideally ideal diode में ये zero होता है, but real diode में ये बहुत कम quantity में होता है, of the order of 10 to the power minus 15 minus 12, and that is because of minority charge carrier. So always remember, current flow whenever the diode is in reverse bias region, the flow of current is from N to P side. The flow of current is from N to P side, and the current is flowing because of the minority charge carriers. Majority charge carriers को ये electric field oppose करेगा, plus opposite direction में नहीं जा सकता, minus इसके साथ नहीं जा सकता, but जो minority charge carriers है वो जा सकते हैं. And third case, case 3, when your diode is forward bias, means when you connect this P terminal to the positive side of the battery and this N terminal to the negative side of your battery. Okay, so again you will be having two component of electric field. One electric field is internal, this will be always from N to P, and now external, the direction of external electric field, because you have connected in this way, so this external electric field will be from P to N. So you can write E net, net electric field will be E external minus E internal, and whenever E net is positive, okay, this meaning to say that E external is greater than E internal, E net is positive. Whenever this is the case, majority charge carrier will start flowing. Okay, you have net electric field from P to N. So this electric field will support the flow of this holes from P side to N side, and it will support the flow of electron from N side to P side. अब आप लोग पूछेंगे कि सर फ्लो हो गया तो डिप्लीट क्यों नहीं हुआ, ये तो और बहुत सब तो मेजॉरिटी चार्ज कैरियर फ्लो हो रहे हैं, डिप्लीट क्यों नहीं हुआ? सो डिप्लीट इसलिए नहीं हुआ क्योंकि ये जो आपने बैटरी लगा रखा है यहाँ पे, जो भी जितने भी फ्लो हो रहा है, सपोज 100 इलेक्ट्रॉन्स फ्लो हो रहे हैं और 100 इलेक्ट्रॉन्स फ्लो हो रहा है और 100 होल्स फ्लो हो रहे हैं, सो दैट अमाउंट विल बी सप्लाइड बाय दिस बैटरी. इस बैटरी का टास्क ही वही है कि उसको सप्लाई करना, तो वो इक्विलिब्रियम कंडीशन मेंटेन रहेगा. तो ये डिप्लीशन रीजन की विड्थ यहाँ पे D3 रहेगी, सो D3 विल रिड्यूस, width of depletion region will reduce because free charge carriers are now supplied by this external battery source. Battery source को हमने इस तरह से लगाया है कि ये external free charge carriers उसको supply करे. So this E external that will support the flow of majority charge carriers. The E internal that will support the flow of minority charge carrier, and that E internal will oppose the flow of minority charge carriers. So E net will be E external minus E internal, and correspondingly I can write that I net current net will be I majority because of this E external, and I minority because of this E internal. So the net current is I majority minus IS. I minority को मैंने कहा है saturation current यहाँ पे. So this IS is known as reverse saturation current. ये fix रहेगा. Okay, so we have I net that is equal to I majority minus IS. Okay, so 1 to 150. Okay, so this I majority, mathematically this I majority is given by this formula IS dot e raised to power Vd by eta Vt. So Vd is voltage drop across diode. So अगर सिलिकॉन है तो 0.5 से 0.7 की रेंज में रहेगा, इस बीच में रहेगा. Eta is ideality factor. So eta is 1 for ideal diode, but nothing in this world is ideal. So the value will be around between 1 or 3. जनरली 1 और 2 के बीच में रहता है, बट किसी किसी केस में 3-4 तक भी चले जाता है अगर ठीक से फैब्रिकेट नहीं किया है. Now you have Vt. Vt is thermal voltage. So we have some surrounding temperature. So that temperature is equivalent to some energy, and that can be converted into a equivalent voltage. So this is the formula K T by Q. So K is Boltzmann constant. The value is 1.38 into 10 to the power minus 23 joules per Kelvin. This temperature is temperature in Kelvin. So whatever the temperature is in degrees Celsius, you have to add 273. And this Q is 1.6 into 10 to the power minus 19 charge on one electron. Okay. So this is the mathematical formula for I majority. So ID, if your diode is in forward bias region having a voltage drop of Vd, and this is the ID. Okay, so this ID is given by IS e raised to power Vd by eta Vt. That is because of majority charge carrier. And this IS that will be in from N to P, that will be because of minority charge carriers. So this is because of majority from P to N, and this is because of minority from N to P. So net current will be this minus this. So I majority minus I minority. That what I have written 2 slides back. So net ID is IS. I can take out IS common. In bracket we have e raised to power Vd by eta Vt minus 1. Okay, and this is called Shockley equation. And this IS depends on many factors: area of this diode, width of the depletion region, doping concentration. IS is a very complex mathematical quantity, so we don't have to derive this, we don't have to remember this. Direct value of IS will be given to you. Otherwise, it depends on the donor acceptor atom concentration, width of depletion region, area of diode, and intrinsic concentration, many factors. And mathematically, graphically, I can represent this mathematical equation like this. So in forward bias condition, okay, this will be the curve, exponential curve, like this, exponential curve. So whenever you will increase your voltage from 0 volt, you will see that up to certain value, the current ID is very close to 0, and after that, Vd does not increases significantly, voltage drop does not increases significantly, current increases drastically. So this point is called V on or V knee, okay, or pinch off voltage or knee voltage or turn on voltage, you can call it anything. And that is 0.7, approximately 0.7 for silicon and 0.3 for germanium. So we say that diode is, even though your diode is in forward bias region, it will be off if V external is less than V knee voltage. Okay, so even if your diode is in forward bias, your external voltage should be, V external should be greater than V knee voltage. Then only your diode will conduct, otherwise your diode will be virtually in off state. Okay, and in reverse bias, you have a very small amount of current, that is IS, reverse saturation current. So for a very large value of Vd, whenever you increases the reverse the reverse voltage. So up to a very large value, maybe it can be 100 or 1000 of volts. So your current value will be practically constant, practically linear. So that's why we called it as reverse, because current is in reverse direction, and saturate because the value is fixed. So reverse saturation current. And after one point, you will see that after one point, the current increases drastically and the voltage drop is now fixed. So this voltage is called ब्रेकडाउन वोल्टेज. इसके बाद आपका डायोड हमेशा के लिए खराब हो गया. बहुत लार्ज अमाउंट ऑफ करंट फ्लो हुआ, इतना कि वो उसने उसकी मेल्टिंग पॉइंट को क्रॉस कर जाएगा एंड ऑल द इलेक्ट्रॉनिक प्रॉपर्टी, डायोड विल लॉस्ट ऑल इट्स इलेक्ट्रॉनिक प्रॉपर्टी. सो वी अवॉइड operating beyond this region, breakdown region. So this is forward bias region, forward bias characteristics in first quadrant, and this is reverse bias characteristic in third quadrant. Okay, so this is the overall functioning of PN junction diode. Now, if you have any doubt, you can ask, and please do revise. Please. I am again requesting you that please do watch that videos, the prerequisite three videos, three prerequisite videos. Otherwise, we will end up in getting confused. Positive कैसे आया, negative कैसे आया, free charge क्या है, ion क्या है, आप उसी में confuse ही होते रह जाओगे. Okay, so 7 participant raised hand. I can address only 1 or 2. We have Devesh. Okay, so now you can allow participant. हाँ जी, आप अपने आप को अनम्यूट करके पूछ लो.
सर रिदम वेटिंग रूम में है, आप प्लीज उसे क्लास में
अब
ले
तो
लीजिए.
मैं इंटरनेट बंद ही करने वाला हूँ क्लास.
सर 15 मिनट से वो बाहर है ड्यू टू कनेक्शन एरर.
देखो, अब अगर मैं, आप खुद सोचो, आप लोग सीरियसली पढ़ रहे हो, अगर मैं हर 10 मिनट में एक बंदे को एंटर करूंगा तो कितना अनोइंग होगा ये. मैं एक फ्लो में पढ़ा रहा हूँ और हर 10 मिनट में किसी बंदे को एंटर कर रहा हूँ, तो कितना अनोइंग होगा आपके लिए. मेरा फ्लो भी आपका भी, आपको तो इट इज पंक्चुअल हो, प्लीज बी पंक्चुअल.
नहीं सर, वो पहले से क्लास में
सही बस
डिस्कनेक्ट हो गया था वो.
एक्चुअली देखो, प्रॉब्लम ये है कि दो तीन बच्चे अननेसेसरीली नाम बदल के उल्टी सीधी मेल आईडी से, जो उन्होंने रजिस्टर भी नहीं कर रखा है, उसका फायदा उठा के आपको भी वो उल्टा सीधा कुछ कमेंट कर सकते हैं जो आपकी डिग्निटी को हार्म करे. तो इसलिए मुझे ये थोड़े से सिक्योरिटी फीचर्स डालने पड़े हैं यहाँ पे. ये सब फैकल्टी के साथ ये प्रॉब्लम हो रहा है, हम उसको कैसे रोक सकते हैं?
Sir, can you please show the reverse bias वाली slide just for a second?
सर खाली लिंक भेज देंगे सर तीनों वीडियो का. सर
हाँ,
पीपीटी एक बार आप शेयर कर दीजिए प्लीज.
वीडियो का लिंक ऑलरेडी एलएमएस पे है, जिसपे मैंने 2 लेक्चर्स ऑलरेडी डाल दिए हैं और ये लेक्चर्स भी आ जाएगा उसमें.
ओके सर,
आप देखिएगा उसमें लिखा हुआ है वीडियो लेक्चर लिंक फॉर पीपीटी. ये तो ब्लैक बोर्ड में लिखा है. मैं पीपीटी खैर भेज दूंगा, मेरे ये पीपीटी इससे अलग है, मैं भेज दूंगा, कोई बात नहीं. हाँ जी, ये है रिवर्स बायस साइड है. पूछिए.
Yes sir, बस नोट करना था सर एक दो चीजें. एक सेकंड.
बेटा, ये वीडियो आपको मिलेगा, टेंशन लेने की जरूरत नहीं है, समझ लो आप. ये जस्ट अभी ये वीडियो को 10 मिनट प्रोसेस होने में लगेगा, MP4 में कन्वर्ट होने में, और तुरंत उस ड्राइव पे मैं लोड कर दूंगा. LMS पे जाना उसको, और वहां पे देखना कहीं बहुत सारे उसमें पोस्टिंग है, तो वीडियो लिंक फॉर MEE बैच, उस पर क्लिक करोगे तो आपको G ड्राइव पे ले जाएगा, मेरी मेल आईडी के G ड्राइव पे ले जाएगा. वहां पे आपको ये चीज मिल जाएगी. 2 लेक्चर ऑलरेडी अपलोडेड है, ये भी हो जाएगा.
थैंक यू सर.
की जरूरत तो नहीं है, जब आप ड्राइव पे जाएंगे हम आपकी परमिशन की जरूरत
नहीं,
पड़ेगी ना.
कोई सारे परमिशन डिसेबल्ड है, कोई भी उसको एक्सेस कर सकता है. बस उसको डिलीट मत करना, ये एक मेरी रिक्वेस्ट है. ये फिर प्रॉब्लम होती है कि आपको अथॉरिटी दी जाती है तो कोई उसको अननेसेसरीली डिलीट कर देता है, तो ऐसे मत करना, ठीक है. हाँ जी, तो ये स्लाइड मेरे पास है. स्लाइड बिल्कुल इससे अलग है. स्लाइड मैंने इसलिए यूज नहीं क्योंकि वो बहुत छोटा स्पेस होता है, उसमें बड़ी मैसी सी हो जाती है. तो बेस्ट इज दैट कि आई विल यूज दिस बोर्ड. एंड वीडियो लेक्चर रिकॉर्डिंग इसके अलावा जो है 3, वो प्लीज आप एक बार देखिए और ये कॉन्सेप्ट को बहुत अच्छे से क्लियर करिए कि ये फिक्स्ड कैसे है और ये फ्री कैसे है. ठीक है, मैंने देखा है बच्चों को ये फाइनल ईयर तक आते भी इसमें इलेक्ट्रॉनिक्स के बच्चे कंफ्यूज रहते हैं. तो प्लीज डू वॉच दैट प्री रिक्विसाइड वीडियो. आगे हम कुछ मैथमेटिकल डेरिवेशन करेंगे, ठीक है. ये सब्जेक्ट मोस्टली न्यूमेरिकल बेस्ड है, तो अभी हमें न्यूमेरिकल पॉइंट ऑफ व्यू से आगे बढ़ना है. So see you tomorrow. We are having one lecture tomorrow. Okay, see you then. Have a nice day.
थैंक यू सर।
ओके, ये 10-15 मिनट में ये वीडियो शेयर कर दूंगा मैं, तो आप LMS पे जाके वो देख लेना लिंक अकॉर्डिंग।
ओके, थैंक यू सर।
Thank you, sir.
ठीक।
Thank you, sir.